Hey everyone. So I'm going to try and keep this video a little bit shorter than the ones that we've done before this, just so that you guys can have some more time to study. And I'm hoping that by this point we've done enough practice questions, but we're going to do some more practice problems involving decimals in this video. So I'm going to do one with lattice multiplication, one with long division, and one with long multiplication. So we'll do practice problems involving decimals. Decimals. Perfect. So, so we're going to start with an example of multiplication involving decimals that we'll solve with lattice multiplication, and then if you want, sort of as an exercise for you guys to try by yourselves, try the lattice multiplication example with long multiplication and see if it gives you the same thing. And when we get to the long multiplication one, try that one with lattice multiplication and see if that gives you the same thing as the first method. So that's just some extra stuff for you to try. The video after this will be a test review. So it'll just be a short sort of breakdown of what you can expect, and if I haven't finished making the test by the time I record that video, the structure of the test will be based on the test review, and if I have finished making the test, then I'll base the test review off what's on the test. So I need to see about when I can finish making that. I've got some other things to do in the next day or two, but I'm going to make sure that I get that test review finished. It's just a matter of when I get the test itself finished. So we're going to work through that, and hopefully everything has been making sense so far. I'm not going to throw any curveballs on the test. I'm not going to make it, problems that are different from the types of problems that we've done. So obviously the numbers might change, but the ideas behind them will be the same, and there won't be any extra tricks that you need to know that we haven't already talked about. So without further ado, let's get on with the first practice problem. So for this one, we're going to start with 421.38 times 7.54. So if we want to set this up as a lattice, we're going to put our first number like so down the side, or across the top, and then the other one down the side. So we have 42138 and 754, like so. And we're going to build our lattice based on this sort of structure. Hopefully that's relatively straight sides. And so we can go and we can just divvy this up. Try to keep the boxes similarly sized when you make them, otherwise your diagonal lines won't work out so well. Obviously my boxes are a little bit off here, but it's a bit hard writing at an angle like this. But yeah, it makes life easy when you draw these diagonal lines in, if your boxes have roughly the same width and roughly the same height. So you have a little bit of a problem with this one here, because the box is a different size. So yeah, try and be careful. If it's easier, draw the boxes first and then fill in the numbers. But yeah, we'll find whatever works for you, and then try to build the boxes and the diagonals based on that. So once you have this set up, remember you want these lines to extend down the outside of the box, and make sure you've got them going in the right direction. And we can put in those decimal points right now, but we're going to forget about them after that until we get to the end of the problem. So we'll put those decimals in there. This way we've got 421.38, and then down the side we have 7.54. So let's go through it. We just fill in all of these boxes. 8 times 7 is the first one. We'll get 56. 8 times 5 is going to give us 40, and 8 times 4 is going to give us 32. Now if you happen to find yourself like on the test getting stuck that, oh, I don't know 8 times 7, but I know 3 times 4, the beauty of lattice multiplication is you can fill in these boxes in whatever order you like, as long as you make sure they all get filled in. So if you don't feel like doing them in this kind of order, that's fine. If you would prefer to do them going across that way, right to left, left to right, bottom to top, top to bottom, or just whatever the easiest problems are first, or whatever the hardest problems are, get them out of the way. You can fill in the boxes however you please. I'm just going to keep going top to bottom, right to left. So if we keep going, we have 3 times 7 is 21, 3 times 5 is 15, and 3 times 4 is 12. Moving on, we get 1 times 7 is 7, 1 times 5 is 5, and 1 times 4 is 4. So the columns with 1s are always a little bit easier to fill in than some of the other ones. Now moving on, we get 2 times 7 is 14, 2 times 5 is 10, and 2 times 4 is 8. And then the last one, we get 4 times 7 is 28, 4 times 5 is 20, and 4 times 4 is 16. Now we just add them up, diagonal by diagonal. So we start in this corner, we get the 2 sitting here by itself. 3 plus 2, that's 5. And then here, we're going to want to be careful that we don't miss anything. 6 plus 4, that's 10. 5 plus 4 plus 1, that's another 10. So in total, that's 20. So we put the 0 here, carry the 2. 2 plus 5 is 7, plus 1 is 8, plus 1 is 9, plus 5 is 14, plus 8 is 22. So we're going to have a 2 down here, another 2 carried up there. Alright, and then here we get 2 plus 2 is 4, plus 7 is 11. And we got a whole bunch of zeros, plus 6 is 17. So we get a 7 there, carry the 1. 1 plus 4 is 5, plus 1 is 6, plus 1 is 7 again. So we get a 7 down there. 8 plus 2 is 10, plus 1 is 11, carry the 1. 2 plus 1 is 3. So that's all the numbers that we need. Now we just need the decimal point. So we sort of connect this decimal point to the other one by going down and across like so. So we basically just take those 2 decimal points and try to get them to meet up. And then once they meet up, they're going to be connected to a diagonal line. And so you're just going to follow that diagonal line all the way down to here. And then that's where you're going to put your decimal point. So in this particular question, we get an answer that gives us, so we had 3177 were the digits there, so we had 31772052 were the digits that we had, and then we put the decimal point in over here, so we get 3177.2052. And if you do this with long multiplication, then you'll find it'll work out the same way. You do the multiplication with the 2 numbers as though there were no decimal points, and you should get 31772052. And then you're just going to notice that from up here, you have 2 digits after the decimal point. Over here, you have 2 digits after the decimal point. So in total, that's 4. So we should make sure that we have 4 digits after the decimal point in our final answer. So that's the first of these 3 problems. We'll move on to the second one now, which is long division. And this one is a little bit longer than some of the previous ones we've done, so I'm actually going to get rid of the title for this. It doesn't serve much of a purpose once we've got the video title that you can use to actually look up the video. So I'm going to erase it for the sake of saving space, because when I was working through this, this was possibly the longest one in terms of vertical space that you need for long division. So for this one, I'm just going to write the problem out once again for the sake of saving space. I'm just going to write out the problem the way I would to start the problem itself, or to start working on the solution itself, and I'm not going to just write out the question off to the side. So for this particular one, it's going to be 521.25, and we're going to divide that by 4. So once again on the test, this divisor will be a whole number, or absolute worst case, it'll just be like 0.4 or something that you just need to move the decimal over 1 spot. I'm going to try and keep it simple. and just have your divisor be a whole number, and then this thing might be a little bit more complicated. So let's start. We'll go and work through it, and remember we can ignore this decimal point for everything except lining it up there. If you wanted to, you could actually line it up at the beginning right now. So we could put it there right now as long as it's in line with this one. I mean, it doesn't really look in line from my point of view, something like that. So we can line that up at the beginning. You can line it up once you start putting numbers up top. You can line it up at the very end. Just make sure you don't forget that decimal point in your answer. So because I've already put it there for this one, I'm going to just leave it there, and we'll work through the problem now. So we start by asking ourselves, how many times does 4 go into 5? 4 goes into 5 once, so we put a 1 up top. 4 times 1 is equal to 4, so that's going to go in here. 5 minus 4, we subtract, and that's going to leave us with a 1. I'm going to actually make that a little bit smaller. And then we pull down the next digit, which is a 2, so we've got that there. Now we ask ourselves, how many times does 4 go into 12? And it goes into 12 3 times, so we put the 3 above the 2. 4 times 3 is equal to 12 exactly, so we put that right here, and we subtract, which leaves us with a 0. Bring down the next digit, which is a 1, so that's going to go right there. I'm trying to keep this small because of the space that I'm going to need going this way. But so we've got a 1 there. 4 doesn't go into 1, but you have to remember to put the 0 up top, so that's why I want you to ask yourself the question, how many times? How many times means you're going to have to answer it with a number, right? So how many times does 4 go into 1? 4 goes into 1 0 times, so we put a 0 there. If you want, you can do that subtraction. That's going to leave you with a 1. Now we pull down the next digit, which is, in this case, a 2. So we put that there, and we don't have to worry about bringing the decimal point down. We don't need that at all. So we get, how many times does 4 go into 12? Well, 4 goes into 12 3 times, so we'll get a 3 there. And we know 4 times 3 is equal to 12, so that will slot in right here. We subtract, we are left with 0. And next we bring down the last digit that we have, which is a 5. Put that here. How many times does 4 go into 5? 4 goes into 5 once, so we'll put that up top. And 4 times 1, because we put the 1 up top, is equal to 4, so that will slot in right here, minus 4. 5 minus 4 is 1. So now we've got a 1 here, and we've run out of digits to pull down, but we don't want to express this with a remainder. We've already started building this quotient with a decimal attached to the end of it, and that decimal is supposed to take care of the remainder. So what we do instead is we turn this 521.25 into 521.250. Which is the same number. I haven't changed the value of this number at all. But now I can pull down this 0. I have an extra digit that I can pull down, and so I'll put that 0 here. Now we ask ourselves, how many times does 4 go into 10? 4 goes into 10 twice. You can extend that line there. So we put a 2 up in line with that 0. 4 times 2 is equal to 8, so I'm going to subtract 8. 10 minus 8 is going to leave me with 2. Once again, we've got this 2 down here, which ordinarily would have been our remainder, but we don't want to have a remainder. So we change 521.250 into 521.250. We just put in another 0 there. We haven't changed the value of this dividend at all. And now we can pull down that 0, which is going to slot in right there beside the 2, and that makes it a 20. Now we ask ourselves one final time, how many times does 4 go into 20? 4 goes into 25 times, so we'll put a 5 up top. 4 times 5 is equal to 20, so that will slot in right here. 20 minus 20 is 0. So that's perfect. We want to finish off with that 0 at the bottom. So I'll bring this a little closer now, so that hopefully you can see it a little bit better, something like that. So our answer, our quotient, is going to be this up top. So we have 130.3125, right? And so basically, we just keep pulling these digits down. At some point, we ran out of digits. We ran out of digits with this 5 right here. So once we did that subtraction, we just added zeros into our dividend, which is right here. So we added a 0 here, and we pulled that down so that we could continue working with this to try and get rid of the remainder. And you finish the problem basically when you either get a 0 down here, or when you notice that you're getting the same digit over and over and over and over again down at the bottom. So like we saw in our previous lesson with when we were dividing things by 3, a lot of the time you'll get that something goes into, that you'll have like, how many times does 3 go into 10? You put a 3 up top and you do the subtraction, you're left with a 1, bring down a 0. How many times does 3 go into 10? And you end up just looping over and over and over again. So if you get to that point, you can just express it the way we talked about before, where you just sort of write that digit that repeats right at once and then put a bar over top of it. But for 4, that's not going to be the case with problems like this. With 3, it's fairly common, right? If you have a third of something, it's going to end with 0.33333. If you had 2/3 of something, it's going to be 0.66666. But for 4, if you had like a quarter or a half or 3/4, that's going to end in 0.25, 0.5, 0.75, right? So those decimals don't repeat forever, right? So with some numbers, you tend to find that those repeating things happen more often, and for others, they don't happen very much at all, if they ever happen for those numbers. So you'll get a feel for that as you do more and more such problems, and just sort of gain familiarity with those kinds of ideas of, if you're dividing by 4, you're going to end with a 0.25, 0.5, 0.75 kind of thing. Sometimes you'll have a whole bunch of decimal points, but then you'll still see things like this pop up. These won't pop up every time, but if you see a 4 here and a 25 up there in your answer, or a 25 here in your dividend, that's probably not a coincidence. If you do 100 division problems where you're dividing by 4, you'll probably see something like that reasonably frequently. Maybe not all the time, but reasonably frequently. Frequently enough that you can start to make that kind of connection. But you don't really have to worry about being familiar with these things to that kind of level. That's sort of just a way to check that your answer is making sense, right? So if you were dividing something by 4, or if you were dividing a whole number by 2, and you're not getting a remainder of 0 or a remainder of 1, so you're not getting a whole number, or you're not getting a quotient that's got something 0.5, then maybe you're doing something wrong, right? If you were doing 7 divided by 2, then that should be 3.5, or 3.5, right? A 3 remainder 1. But if you were doing 8 divided by 2, then you should get just a whole number 4. If you were doing, some much larger number, if you were doing something like this, divided by 2, and you were getting something 0.333, chances are you're doing something wrong, right? Because those kinds of decimals don't show up when you're dividing by 2. So those kinds of things are just little things that you can check for certain numbers to see if your final answer is making sense, right? So if if you treat these questions as, what were the numbers for this one? If you treat it as, you go out and buy something really fancy with 4 people, or you plus 3 people is going to be 4 people total, and the bill is $525.25, right? Then that's the question we just did, $521.25 split 4 ways. So among 4 people, if you're getting an answer of like 1,000, that's saying that each person would have to contribute $1,000 to pay off this bill. So you can do those little checks to see, okay, does my answer really make sense? So in this case, we got an answer of, for this problem, we got 130.3125. Now obviously in the context of money, having more than 2 decimal places doesn't really help, but you can check with like this much, does 130 make sense? It makes more sense than something like 1,000, right? Even if you're not doing all the math in your head of 130 times 4 is 520, so it all checks out that way. Just do a rough estimate, right? This should be way less than 500. It shouldn't be as small as like 13, let's say, right? So you can always do those little checks to make sure that your answer is right. But if you get the process you know, down pat, then you don't have to worry at all about those checks, because if you're doing the process right, then you won't really find yourself in a position where you need to do those checks to see if your answer makes sense. You'll just have the confidence in your answer that you just call it a day as soon as you finish the problem. It is always good to check though. Sometimes you make mistakes. When I was working through these problems the first time, I carried a 1 instead of carrying a 2, so it's always good to go over it again, double check your answer, just go through the steps again in your head and see if you're getting the same numbers. So we're going to finish off this video with one more multiplication problem, and this is going to be a long multiplication problem. So we're going to do 871.504 times 2.319. So we're going to write these out as we would for long multiplication. So I'll put these over here. So we got 871.504 times 2.319. Now remember, when you're doing this with multiplication, with long multiplication, you don't really have to worry about getting the decimal points to line up when you're writing them out like this. In this problem, it just happens to work out that way, and it would have worked out that way for the previous problem because we have the same number of digits behind the decimal point. But in general, you don't have to worry about that. So for this, we're going to go through the problem as though there were no decimal points, and then we'll just chuck in the decimal point in our final answer once we finish all of the multiplication and the addition. So if we start, we get 9 times 4 is 36, carry the 3. 9 times 0 is 0, plus 3 is 3. 9 times 5 is 45. 9 times 1 is 9, plus 4 is 13. 9 times 7 is 63, plus 1 is 64, carry the 6. 9 times 8 is 72, plus 6 is 78. Alright, so far so good, I think. Now we put our placeholder down here. Do not forget this placeholder. If you forget it, it'll mess up your answer entirely. So make sure you have that placeholder. If you don't like putting an X, you can put a 0. You can put a 0 in an X, or an X inside of a 0. You can put a smiley face. I don't really care. As long as you find something that doesn't confuse you, then it's fine. So the next one is a 1, so we don't even have to do the calculation, right? We can just write this out. 1 times 4 is 4, 1 times 0 is 0. None of these digits are going to change, so we just take that and we just copy it out down here, but of course we're ignoring the decimal point. So we get 5, 1, 7, and 8. Right, next up we have to put 2 placeholders because we moved over 2 spots from where we started. And we're working with this 3 now. So we do 3 times 4, which is going to give us 12. Carry the 1. 3 times 0 is 0, plus 1 is 1. So we put that there. 3 times 5 is 15. Put the 5 there, carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 7 is 21. Put the 1 there, carry the 2. 3 times 8 is 24. Plus 2 is 26. So all good so far. We can cross out those numbers that we've carried to make more room, or really to just avoid confusion when we do the next line, so that we know which number we've carried and which numbers we need to worry about, which numbers we don't. So we put our 3 placeholders down here, and then we do the last bit, which is with this 2. So we do 2 times 4, which is going to give us 8. 2 times 0 is 0. 2 times 5 is 10, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 7 is 14, carry the 1. 2 times 8 is 16, plus 1 is 17. So we get that there, and then we want to add all of these lines together. So we put that there, and we can add this now. So these x's, remember, they're in place of zeros. So we get 6 plus 0 plus 0 plus 0 is going to give us a 6 down there. 3 plus 4 is 7. 5 plus 2 is 7 again. 3 plus 5 is 8, plus 1 is 9, plus 8 is 17. So once again we get a 7 there, but we have to carry now. 5 plus 1 is 6, plus 4 is 10, plus 1 is 11, so we get a 1 here, carry the 1. 8 plus 7 is 15, plus 4 is 19, plus 1 is 20, so we put a 0 there, carry the 2. 8 plus 7 is 15. I sort of add them up in sort of just kind of any order that works for me. I like that 8 and 7 make 15, and then I can see that this 3 and 2 are going to make another 5. So I get 8 plus 7. Those aren't decimals, those are just me pointing. So we get 8 plus 7 is 15, and then we get 3 plus 2 is 5. So that's 20 right there, right? So we got 8 plus 7 is 15, 3 plus 2 is 5, that's 20, plus 1 is 21. So I might jump around a little bit when I'm doing the addition, but it gets the job done, right? So we got 8 plus 7 is 15, 16, 17, 18, 19, 20, 21. So we have the 1 down there, carry the 2. 6 plus 4 is 10, plus 2 is 12, carry the 1. 7 plus 2 is 9, plus 1 is the 10, carry the 1. 1 plus 1 is 2. So right now this is an insanely huge number. And so what we want to do now is our last step, which is, or you could say our second last step, which is to count the number of digits after the decimal point in these two factors. So up here we have 1, 2, 3 digits after the decimal point, the 5, the 0, and the 4. And then down here we have 1, 2, 3, the 3, the 1, the 9. So in total we have 6 digits after the decimal point. So we start here and we just count 6 spaces to the left. So we go 1, 2, 3, 4, 5, 6, and the decimal point is going to go right there. So that would be your final answer, would be 2021.0177776. Alright, so that matches what I got earlier. Perfect. And if you wanted to, you could always do a little check that to make sure that this is making sense, right? To make sure that the answer is making some sense. So for instance, for this you could say that this is just, let's say, 870 roughly, times, we'll just call that 2. And then that might be something that you could even calculate down the side, right? 870 times 2, 2 times 0 is 0, 2 times 7 is 14, 2 times 8 is 16, plus 1 is 17, so that's 1740. It's reasonably close, right? We've taken off a whole bunch of extra stuff from our answer, but you can see by just going through it quickly that it should be something like a 4-digit number, but if you ignore all the decimals, right? If this was a number like, if we were getting an answer like 20, or an answer like 202,000 or something, right? Then chances are we're getting the decimal in the wrong place, if you just do that quick check down the side. Right, so yeah, so that's how this works. So hopefully now it makes sense how to multiply both with long multiplication and lattice multiplication when you have decimals. Hopefully division is also making sense, and hopefully the little sort of tricks for how to check whether your answer is making sense are also working out. So remember that when you're checking it, it might not be exact, right? Like if I did 870 times 2, I've changed a lot of stuff, right? I've just thrown away this 1.5, and I've thrown away that 0.3 over there. Maybe I should have done 871 times 2.5, right? That would make quite a significant difference to my answer. But that's just sort of to see, you know, am I on the right track? Should my answer be more like 2 or 2,000 or 2 million, right? So that just gives you an idea of, is my decimal in the right spot? But yeah, so that's everything for multiplication and division, with and without decimals. So the next video that I'll put out will be a test review. It's going to be fairly short, so it won't occupy a full class. And if you guys happen to be at the point where you've run out of class time before your test, then just take 5 or 10 minutes out of your weekend to watch that. It won't be much longer than that at all. And you guys have my contact information, so you can get in touch with me if you need any more help before your test. And I will see you guys in the test review. Have a good one.